Once NWS meteorologists have determined that a hazard warrants an advisory or warning, we utilize a software called warning generation, or WARNGen for short. This software allows us to track a single point or a line or cluster. From there, the storm motion can be determined by toggling back and forth in time. A first guess box is then created by the software based on the storm motion and expected trajectory. The forecaster can then scale the box as they desire. Once the forecaster has determined which spatial areas will be warned, they can then select the hazard they are warning for, the length of the warning, as well as the type of language used. This is where we determine if severe thunderstorms are capable of 70-mile-an-hour winds and 2-inch hail, or if we want to use language that describes a large and violent tornado has been confirmed. WARNGen also has a large database of geospatial information that captures larger communities, like those across the Metroplex, or specific landmarks such as airports, racetracks, or parks. During the night of the Dallas tornado, we did observe a dual polarimetric tornado debris signature associated with this storm. The dual pole tornado debris signature requires there be a velocity couplet, CC of at least 0.8 or less, and reflectivity of at least 35 dBz. A differential reflectivity of near zero is optional. One might ask, if there are pieces of wood being hurled about, why would the ZDR fall to near zero? This is because objects within the debris cloud will tend to tumble, and the effective shape is spherical to the radar. Note that the appearance of a tornado debris signature confirms the circulation is in contact with the ground. The lack of tornado debris signature does not mean that a circulation is not in contact with the ground. And also keep in mind that debris signatures may not be evident at greater ranges from the radar. So we have all the requirements, as we can see in the top image, for tornado debris signature. We have a velocity couplet, CC less than 0.8, and reflectivity of at least 35 dBz. We even have the optional near zero differential reflectivity. If we take a cross-section, we can see the updraft tower in the reflectivity field, as well as the transportation of the debris associated with depressed correlation coefficient values and near zero ZDR values. Here is an animation of the FWS radar imagery at the 1.3 degree elevation angle from 8:50 p.m. to 9:20 p.m. You can see the very pronounced hook echo as well as the tight rotational velocity couplet. We also see depressed values of correlation coefficient and ZDR, and concurrent with the appearance of these signatures was the video capture from a viewer of a condensation funnel and debris cloud associated with the EF3 tornado that ripped through the northern portions of Dallas County in October of 2019. If we take a look at the three-dimensional model of the 50 dBz layer that has been stitched together from the FWS radar, this is the end result. If you look at the ES in west, you can see the forward flank downdraft area. As the loop plays, you can see the portion of the right-moving supercell that produces the tornado across northern Dallas County. In total, there were 10 confirmed tornadoes across North Texas on the evening of October 20th, 2019. The highest rated tornado track was across northern Dallas County, with peak estimated wind speeds of around 140 miles an hour. The EF3 tornado path was actually visible from satellite imagery initially. An EF2 tornado also tracked through Garland, with a handful of EF1 and EF0 tornadoes across Collin and Ellis counties. While there were some injuries, there were no known fatalities associated with this tornado event across North Texas. Here's a brief recap of what we've talked about in the presentation. We have discussed basic weather radar principles and provided an overview of some of the base and dual pol radar products. We've also discussed convective conceptual models and gone through a warning process walkthrough. If you are looking for additional SKYWARN resources, please visit us on the web at weather.gov/FWD/SKYWARN. In addition, if you have photos or videos that we can use in future SKYWARN talks, please email them to our webmaster account listed here at sr-fwd.webmaster@noaa.gov.